Hello, Professor Sargent here with you again. This is going to be about conditional probabilities. And to kick this off, I'm going to refer to a video that you may have already seen, but I'm changing the question. Here's the question we're going to take a look at. In the question, you're going to start off by seeing whether a student is satisfied, neutral, or not satisfied. And it's going to be broken down by class standing: freshman, sophomore, junior, or senior. And what we're going to take a look at now is, given that that student is a junior, what's the probability that the student is satisfied? So here we go. Okay. Now here we go. That's interesting. They were showing us totals, but they don't show up in the download. So there's our total number satisfied, regardless of class standing. Do the same for the other two. Get our totals. Let's also go this direction. Then whether we add these three, it's going to give us 296 plus 78. Should be 374. As you get the same going this direction. And I do. The easiest way to look at this problem would be to consider restricting the sample space. Instead of looking at all 374, let's narrow down the sample space to just looking at the 85 juniors. We saw that 62 of the juniors were satisfied. I'm not worried about trying to reduce this or express it as a decimal or anything. However, I want you to notice something. Since we've been talking about juniors and juniors that are satisfied, we could see from the table that out of the total 374 in the entire sample space, of all the 374 students, 85 of them were juniors. And also, I got that 62 from the intersection of the row and column for junior and satisfied. What happens if we were to multiply the 62 over 85 by the 85 over 374? The 85s would cancel, giving us the 62 over 374 that we had for the intersection, the probability of junior and satisfied. So what can we glean from this? If we call the event of the undergraduate student being satisfied with student government event B, and the event of that undergraduate student being a junior event A, replace the word given with this vertical line segment. Notice, by the way, that the way I wrote it here, satisfied given junior, was opposite from a more natural language approach here. So we're looking at for the probability of B given A, we had 62 over 85. The 85 over 374, that was the probability of A, and we multiplied them, and we got the probability of the intersection, probability of A given B. Since our focus was on this probability, if we divide both sides by the probability of A, then we come up with this important formula for a conditional probability. What's the probability of B given the condition of A? This is not a fraction. However, I like to remember this by noticing that we are dividing by the probability of A. Also notice that the order of intersection does not matter. A intersect B is the same as B intersect A. Again, the order of intersection does not matter. However, if I swapped A and B here and here and here, then I would come up with the probability that of A given B is equal to this. But again, the order of intersection doesn't matter. So what really matters is, since we're talking about the probability of A given B in this version of the formula, then what I'm dividing by here is the probability of B. So again, B given A or A given B, we're not talking about a fraction, but based on the order of that, you can see what you're dividing by there. Some more examples in just a bit.